This video takes a look at normal distribution and the 68, 95, 99.7 rule. Okay, so if we are told that our data set has a normal distribution or is normally distributed, then we know we can predict the distribution of that data, what that will look like. We know that it will be centered around the mean. So if we think about drawing a line from the top of our curve down to this center point, that would be where our mean would be. If we go out one standard deviation, because remember standard deviation tells us how varied our data is, so we have a value for standard deviation. If we go out one standard deviation, and by that I mean we take the mean and then we add one standard deviation. Okay? Then we can draw a line here. And we subtract one standard deviation on the other side. And draw a line here. Then the 68, 95, 99.7 rule tells me that 68% of my data is between one standard deviation above and one standard deviation below. So 68% of the data is between one standard deviation above the mean and one standard deviation below. Okay? So if we think about that, we know that what's in these two parts that we've identified is 68% of our data. Okay? 68% of our values lie in there. If it's 68% and it's centered around the mean, then we can go ahead and divide that into two parts, and 68 divided by 2 means 34% is here and 34% is here. If we keep going, we can go out. We know our rule also tells us that 95% is within two standard deviations of the mean. So if we go out another standard deviation, so we're adding two standard deviations and we're subtracting two standard deviations from the mean, then we know that we have another part of our curve that includes data, not as much because we can tell that's a smaller space. Now we know that all together, those parts that are shaded blue and red, make up 95% of our data. So we've already accounted for 68. 95 minus 68 gives me 27, so we've got to account for 27 more percent. Again, half is below and half is above. So if we think about the percentage that goes with these blue parts, that would be 13.5% on each side. So we have 34% in the red area on each side, and we have 13.5% in the blue area on each side. We're going to go out one more standard deviation, so we're going to say plus 3 standard deviations and minus 3 standard deviations. And we know that's an even smaller area. This area that's green contains the difference in 99.7 and 95, because that's what our rule is. It's 68 in the middle, then 95 in the red and the blue, and then 99.7 in the red, the blue, and the green. So now we know that each green part contains 2.35% of the data. So now if we added up all those percentages, we would have 99.7. Our data set has 100% of our data, so 0.3% is outside of these 3 standard deviations. So that means 0.15% is above 3 standard deviations, and 0.15% is below 3 standard deviations. So that's what normal distribution looks like, and that part doesn't change. Every time you read normal distribution, you know that these percentages are true. What does change is the mean and the standard deviation of our data. So let's take a look at a particular problem. When robin eggs are weighed, it turns out that the weights have a normal distribution with a mean of 17.5 milligrams and a standard deviation of 3.5 milligrams. Use the 68, 95, 99.7 rule to answer the following. What percent of robin eggs have a weight that is between 10.5 milligrams and 17.5 milligrams? Okay, so there's a lot of information there, but we know it tells me that they have a normal distribution. So that's the key words that we're looking for to know that we can use this bell curve. We know that the mean is in the center, and our mean is 17.5. So I'm going to label that and draw my line. And that is not straight, but you get the idea. If we go up 1 standard deviation, then we would be adding 3.5 to 17.5, and that would give me 21 milligrams. If we subtract 3.5 from 17.5, that would give me 14 milligrams. So those are my values for 1 standard deviation above and 1 standard deviation below. Okay? So we already know that 34% is in here and 34% is in here because we got that from the fact that it's normal distribution. If we keep going, we want to go up another standard deviation and down another standard deviation. So we take the 21, we add 3.5 because that's our standard deviation, and the next value will be 24.5. We subtract 3.5 from 14 because we're going down on the left side, and we get 10.5. So that's our second standard deviation away from the mean. And we know in that part we have 13.5% of the data. And in this part we have 13.5% of the data, because that's true for every normal distribution. If we keep going, we could say, all right, we add 3.5 to 24.5 and we get 28 milligrams. We subtract 3.5 from 10.5 and we get 7 milligrams. So 2.35% of our data is in each one of those parts. Now, I think we can answer the question already without going out further, but we could go out one more time because we know we still have the 0.15% that's above and 0.15% that's below the standard deviation. But the question that it asked me is what percent of robin eggs have a weight that is between 10.5 and 17.5. So on our chart we're looking for 10.5 to 17.5. When we look at that, we know that we start here because that's between 10.5 and 14, and then we keep going all the way up to 17.5. So basically we're looking at these two sections of our data, and again my middle line was not straight, but you get the idea. So we're adding 13.5% and 34%. So our answer would be 13.5 plus 34 gives me 47.5% of robin eggs have a weight that is between 10.5 milligrams and 17.5 milligrams.